surface areas and volumes.
Okay. We revised the formula of surface areas and volumes of 3D figures we have already studied before. So the formulas we discussed, and in the last lesson also we discussed how to find the surface areas of combined figures. If we combine two 3D figures, how to find the surface area. Some example questions we discussed. So we move to the next subtopic, that is volumes. Volumes of the combined figures. Okay, so just to revise the formulas. What is the formula for a volume of a cuboid? Volume of a cuboid. What's the formula?
LBH.
LBH is the formula. We know length, breadth, and height. If that is given, we can use this formula. Next, for a cylinder, what's the formula for a cylinder to find the
Pi r square h.
pi r square h? Pi r square h. That is base area into height, right? This is also base area into height. L into B. If you keep this vertical, L into B will be base area into height. Here also base area into height. Then next figure, suppose sphere. What will be the volume of the sphere? 4 by 3. 4 by 3 pi r cube. 4 by 3 pi r cube. And next figure, a cone. For a cone, suppose L is
1 by 3.
Yes.
Pi r square h.
1 by 3 pi r
L.
square h. Pi r square h, correct. 1 by 3 pi r square h is the formula to find the area of a cone. R, H are given. L, and no need of L in case of volume. Okay. Then next one, okay, cube. For a cube, what is the volume to find the volume?
A cube.
A cube. A cube. That's fine. Okay. Next one, last one, hemisphere.
2 by 3 pi r cube.
2 by 3 pi r cube. 2 by 3 pi r cube. Okay, that's also just half of the full sphere. 2 by 3 pi r cube will be the half of 4 by 3 pi r cube. Yeah, we write they are same. Actually, that is a curved surface. We can say curved. If we say curved surface area, no mistake there, because the face is curved. Okay. Because there is only one area, we simply say surface area or total surface area. Okay. So I think the formulas are clear. So we will connect some combination of these figures to make some 3D figure, and we want to find their volume. So this is some way we can say this is comparably, this is little bit easy than the previous picture, because in the previous picture some part we want to delete when two figures are combined, as the previous question. In the previous question, when one 3D figure is cut out from one picture or one is connected, some base or some side may be deleted in the case of surface area. But in the case of volume, the question will be straight. The relation will be sometimes two shapes are connected. The volumes we want to add. Nothing to remove. If two are connected, we want to add. And if something is cut out from some other, we want to subtract direct. So question is direct, but anyhow, some different types of questions are possible. We will see. Okay. Now we will discuss the solved problems in the textbook. Solved problems in the textbook. Then we will wind up the lesson. Okay. And in next lesson, we will continue the volumes of these combined figures. Okay. I am not writing here, but I will show in the textbook and I will explain. We can discuss. Okay. Okay, look here. This is the first question given in the textbook. I shall zoom a little more. Okay. This is the first figure. We can read the question and I will explain how it is solved in textbook. Because already solved here, you don't have to write in notebook also. You can read from the textbook. Okay. So this is a simple question, not simple, some volume, different way it is asked. Some sub questions are there, but the volume, finding the volume is very simple. Look here, Shanta runs an industry in a shed which is in the shape of a cuboid surmounted by a half cylinder. If the base of the shed is of dimension 7 meter into 15 meter and the height of the cuboidal portion is 8 meter, find the volume of air that the shed can hold. Further, suppose the machinery in the shed occupies a total space of 300 meter cube and there are 20 workers, each of whom occupy about 0.08 meter cube space on an average, then how much air is in the shed? The remaining air. Okay, remaining space will be air that we want to calculate. So the first half is very simple. We want to find the volume of this figure. A cuboid surmounted by a half cylinder. So you want to add the volume of this cuboid and the half the area of the cylinder, right? Add the volume of this cuboid and the half the area of the cylinder. This is a half cylinder. Okay. So all the measures are given. To find the area of this cuboid, we need a length, breadth, and height. Are all these given for this cuboid?
Yes.
Yes, right. The dimension is given. The base of the shed, the dimension is given 7 into 15. 7 into 15. So yeah, the length, breadth, and height can be chosen as 7 and 15. And height of this cuboid is given. That is 8 meter. So L, B, and H are given. And to find the volume of the cylinder, are all the measures given?
Diameter.
Given, yes, the diameter is given. So diameter will be 7, so radius will be its half, and height is just 15 will come, same
15.
Same 15 will come. So R and H are given. What we need, the formula is formula pi R square H. So pi R square pi is, we all know, R and H are given. So then we want to take only half. So it is solved here. I will show here. So what we want to have, volume of the cuboid plus half volume of the cylinder we want to do. Volume of the cuboid plus half volume of the cylinder. So how will come? So 15 into, so we can substitute the values. Pi r, what's up, cuboid? Cuboid, the volume is pi LBH. LBH, so 15 into 7 into 8. Then, okay, volume of the cylinder will be half the volume, half into pi value 22 by 7. Then radius will be 7 by 2. So radius square will be 7 by 2 into 7 by 2 into H. H is 15. So values are substituted. The formulas are now not written here, but directly the values are substituted. Then simplifying this, you will get 1128.75 meter cube. That is the total volume inside this shed. So if this is an empty shed, inside there is nothing inside the shed, the amount of air inside the shed will be that much meter cube. That is 1128 meter cube, 0.75 meter cube. But inside there are some objects, some machines are there. So all such things have total volume of 300 meter cube. And there are 20 workers. Each of them have an occupy some volume of 0.08 meter cube. So subtracting these two volumes, you will get the remaining volume that the air will contain. Okay, so for one worker 0.08 meter at average. So for 20 workers we want to multiply. 20 worker, how much space will take? So we want to multiply. So it is given here. The total space occupied by the machine will be 300 meter cube. That is given. The total space occupied by the workers will be 20 into 0.08, because one worker occupies 0.08 meter cube place. So multiplying this, you will get 1.6 meter cube. So from the total volume of the shed, you want to subtract the sum of these two volumes. That will be the remaining space, the remaining volume that the air can contain. Okay. So adding 300 plus 1.6, then subtracting that sum from this number, you will get 827.15 meter cube. That will be the volume that air contains.